Alright. American Railway Signal Principal Practice is Chapter 21, your hump yard systems. Power switch machines. Metal 6 switch machine. Electrical operation. Metal 6 switch machine is mounted on the tie plates on the end of the two tie plates, similar to the switch in electric interlock. Figure 35 shows the machine is with its covers removed. The motor and the train of the gears are similar to those described in Chapter 12. 19. Electrical interlocking with the connection to the throw rod. However, the difference because with the travel feature of the two levers, the one fitted with the roller and called with the lever, and the other fitted with the cam and called with the cam. That is fitted with the bottom of the case of the provided with the minimum of the driving throwing rod. They are connected to the together. Normally used move as a unit because of the roller is held with the spring of the brush with the detent with the center of the cam. The roller on the other end of the lever begins with the cam of the main driving gear, which causes the unit to pivot and throw the rod in connection with the other end of the cam. This shows figure 35 shows the diagram of Model 6 switch. By means of the roller and fork arrangement, which causes the throw rod to move at the formal normal operation with the two levers moving the unit the switch of the trailed. One of the cams moved since the roller of the cam rests with the detent with the cam is moved over the detent. The cam is allowed to pivot respective of the lever. The sufficient stroke is provided either the way of the detent. So regardless of the position of the switches, the full movement of the points can be obtained with the trailing through without the necessity of the moving lever connected to the main gear. After the switch has been trailed through the previous described, it is necessary to move the control lever to the opposite position so that it will agree with the switch points at which the time the roller will drop back and the detent. Again, connect the lever and the cam together. From then on, the machine operates formally. The travel feature also serves to make the switch machine reversible, even though the points may be blocked, since there is sufficient power to be forced with the roller out of the tent and the cam of accomplishing the same with the result as the switch trailed through. Hence, it is impossible to stall the motor obstruction with the points. Therefore, the fuses are never blown unless the short circuit develop. But the further use is made with the trail, with the feature that the cam is used with the point of detection on the cam is mounted with the second, which the cam operates with the point detector. Adjustment of the cam is 1/4 of an inch between the point of the stock rails and indicated with the contacts are controlled with the indication of the cam as used with the selecting indication. The pull charger mechanically operated with the cam attached with the end of each of the driving gear. The necessity for therefore being stroke completed without once it has been started. Otherwise, circuit could be opened with the point of the left of their center of their transform indicated lights with the frequently mounted in the switch machine. The track circuits are used for the auxiliary and is mounted on the end of the machine. The housing of the track transformers resistance occasionally. The rectifier figure 36 shows the track circuit control of the Model 6 switch machine, including the control lever, the lever lock. The indicating lights of the circuit is with the switch operation similar to be used in the electrical interlocking exemption for the reverse pole charge changer coils are omitted. Um, 43. When the tracks are used, they are usually operated with the alternating current source. The rectifier to operate the direct current. The relay has an independent coil which is connected with the operating circuit with the machine, which provides with the first that in order to energize the relay of the track circuit must be unoccupied. Second, that one has the once it has been energized, the switch machine operation is started, but the track circuit can be shunted and still machine closed with contacts in the relay, which the switch machine operation is completed. But they ensure that once the switch has been started to move, it will continue until the operation is completed. Therefore, the laying out of the track circuit enough the distance ahead of the point is provided so that the average normal speed of the car will not reach the point before which the switch movement is completed. The shunt long time of the track circuit is also a factor in the distance between the head of the points. The alternating current directing current track circuit that the track relay shunted with 0.5 hundredths and 8 hundredths per second. Alright, the lock and the control lever in the series where the operating circuit is energized immediately with the control levers operated, locking the lever in the position with the movement of the switch machine is completed with the previous and other movements. The control lever in which is made with prior to the completion of the switch machine operation might open the operating circuit and leave the switch points on the center. Other types of track circuits are used in the general principles employed are similar to that already described. Figure 36 shows the track control circuit with the Model 6 switch machine. You have your 50 feet to 25 feet minimum for the retarder and switch signal, which goes through the switching machine through a couple and control the lever on the tower and the track relay system. Two different wires. Directing, acting, switching movement, the electropneumatic operation, the direct acting with the switching movement, the figure 37 consists essentially with the air on an air cylinder piston rod of the, which is connected directly to the throw rod of the switch of the two electropneumatics, one of which will control the normal position of the switch, the other of the reverse position, is very similar with the switch valve of the cylinder described in Chapter 18, electropneumatic interlocking, except with the locking devices. The valve D is not used, not locking, a no lock rod, lock magnet, or motion plate is used, which is switch movement. The switch may be trailed through any time of the air cylinder, merely acting as a cushion. When the track circuits are used, the control circuit is arranged so that the switch is trailed. That the operation of the switch circuit control or it causes the air to be admitted to the cylinder as holds the switch as in the trailed position until the track circuit again becomes clear, and when the switches will return to the original position again with the agreement with the control lever. Thus, an engine with or without cars trails partially through the switch and then reverses in the direction, therefore no splitting of the switch. Figure 37 shows the direct acting switching movement of electropneumatic operation. Figure 38 shows the track of the control circuit of the directing acting switch movement. The track circuit is occupied by shunting the track relay, energizing and maintained with the holding circuit of the wire B12A on the normal and reverse magnet, as the case will made depending on the magnet was energized at the time the relay was shunted due to the speed of the direct acting switch movement as well as the speed of the shunt of the circuit bit. Distance of 22 feet ahead of the switch point at the beginning of the circuit is ample of the ordinary yard speed. The two-position cam in which the switch circuit controller is adjusted will open close mid-stroke, and at the mid-stroke, the arrangement if the switch is trailed through the switch point are held with the trail position as long as the trail circuit is occupied. When the track circuit is vacated, as the position returned to the former position, corresponding with the position of the switch lever in its control machine. Alright, so the skate layout. Skates are used for the classification yard with emergency measures to stop cars. The general principle of the device is quick. The movement does not take more than 1 second from the time the control lever is moved from the skate is placed on the rail. Alright, figure 38 shows the track control circuit for the direct acting switch movement, electropneumatic operation, the switch control lever with the RWK and NWK, the battery charges, we have the switch ignition indication lights, also going to the switch control magnets and the piston cams and on a relay, on a couple relay switches at your turnout. The switch machine is reversible mid-stroke, so that the skate is thrown against the wheels. It may be returned to the original position. The connection between the skate and the support and such of the skate can be taken away with the car wheel without shock of the mechanism. The skate, after being taken with the wheel, is carried out by the placement of the skate clip and by hand. Usually, the yard crew will, when taking the car off the skate, brings back the skate and maintain or place it under the skate clip. Skates are located on the classification track of about 200 to 300 feet beyond the switch retarder on the end of the rear yard. Alright, power skate machines. Electric operation. Electric skate machine is figure 39, consists of the train gears driven with the reverse motor with the shaft of the driving gear being extended through the housing and equipped with the crank to which the link is connected through the purpose of the moving of the skate clip. The skate is attached to the clip and means with the wedge arrangement of the ball and detent. The wedge is parallel into the track of the skate, slides off easily when the car wheel takes it away. The ball backed up with the spring skate is pressed into the tent wedge, which holds the skate with vibrating off the wedge and is not placed on the rail. The magnet shoe type of the brake connected with a series of the motors is used in stopping the holding the skates as opening and closing position. Contacts operated with the cams are used with the controller to open and close circuits at the proper time. Figure 39 shows the power skate machine electric operation. Alright, the circuit for the controlling movement is shown in figure 40 with the controlling lever of the two position, one position energizing one of the field coils from one direction of the rotation into the other position, energizing the other field for the opposite direction with the rotation of the controller. Contacts are in series with the control wires cut off of the power with the proper point at the stopping mechanism without overrun. Alright, I'm going to flip this. Alright, you have your figure 40 control circuit with electrically operated skate. You have 230 volts with 115 volts, 230 volts plus a neutral 230 volts. Control lever going into the circuit breaker, circuit control skate on the circuit control on the skate and the brake coils on the motor. at 1, 2, and at the track. All right, your electropneumatic operation. Electropneumatic escape machine, the figure 41, should simply arrange for the lever the movement of the piston. Small cylinder is placed with the skate rail. When the piston moves and removes the skate from the rail, the piston returns the emission release of the air of this. For this, the cylinder is controlled with one magnet. When the energized emits of the air, the cylinder forcing the piston out, the placing of the skate on the rail. When the magnet is de-energized, the cylinder is exhausted. The atmosphere, the spring forces the piston back, removing the skate. The control circuit of the two wires controlled with the operation of the toggle switch in the control machine. Figure 41 shows the power skate machine and the electropneumatic operation. Control machine. Control machines are located in the towers of strategical points of the yard. For these points of the advantage for the operators, can you see either the entire switching area to judge quite accurately with the speed of which the cars are traveling. These towers are so located that the operators can approximately amount the space left on each of the track, release the cars into the tracks that are spread, which carry them either the couple or very near. So the floor of the tower is usually 15 to 20 feet above the top of the rail. The towers are equipped with windows so that there is a minimum of obstruction to the view of the operator. There are usually three towers are used, one located with the junction switch and the other two further down the yard, one on one side, one on the other. The operator in the tower and the junction switch controls the retarder and the humping lead, usually in the sub leads. The operator in the other two towers control the retarders in advance with the group, the classification tracks and switches in these groups. In practically all the cases, the switches immediately in the rear of the retarders have the controls in the same tower in which the retarder controls the located, since the better for an operator to adjust the car spacing for the switches he controls. General principle: the arrangement of levers in the machine is compact with the large number of the function can be controlled by one operator. The number of the arrangement of levers is so much that they may be readily located. Indication of the various splits provided with whatever necessary. It must be, in most cases, the indication of show the position of the switch occupancy of the track circuit is provided. The control machine is designated so that the operator may be seated and still have clear view of the entire yard, but at least the section of the yard under his control. The control machine is so designed that all the levers can access possible maintenance purposes without interfering with the operation of the plant. The control machines are built with a sloping top of the projection in the front, under which there is room the operators need. The top of the machine is divided into sections and panels. The levers are attached to the panel, which is hinged at the top of the motor, making the levers easily accessible to maintenance purposes. Usually, the switch levels are arranged with a group of the similar to the order in which the cars pass through the switches in the yard. Whether the junction leads with the switch lever is either equipped with a red handle set slightly apart, but the other switch's lever distinguishes it from the others. Insofar as possible, the retarder levels are located just above the switch levers, control switches, and immediately following the retarders. Alright, the number of the switch levers agree with the practicable with the tracks in which switch leads. One method of the numbering, for example, the switch will be reversed and lead the track to the lever number 1. Another method is each switch bar bears two numbers, the number of the bearing being extremes of the track numbers to which the switch leads. For example, if the switch leads to the track number 1, reverse to end, and when the reverse into the track 2 to normal, the lever number would be number 1, 2. Retarder levers are usually numbered in the same switch but immediately in the rear. Skate levers are normal number of the tracks on which these skates is located. The switch lever usually at the bottom of the panel. The retarder lever is next to above the skate and lever at the top, shown in Figure 42. Figure 42 shows the electrical control machine. Alright, your electrical system. Control machines are shown in Figure 42, 43, and 44. All levers have been forward or backward movement. The forward normal position being away from the operative panels, and to which the top of the divided are two levers in width. The accessibility and maintenance of figure is shown in Figure 43. 43 shows the electrical control machine with the panel raised. The retarder lever, the forward position for the open position, other of the four-step retardation lever that's held with the various position with the means of the roller backed up with the spring pressure dropping the into the notches. Figure 43 there is then the click as the roller drops into the notch. This makes it possible for the operator to move the lever to define its position, listening to the click instead of watching the lever. Sometimes it's necessary to look at the lever and to find out what the position which is located in plate with the front of it is described with the numbers and when which the match with the top of the panel to the mark of the various positions. Alright, the switch lever has two positions, forward and normal, backward from the reverse. Indication lights located directly above the switch lever. The normal light over the reverse light L at all times except for the switch machine. And if it in a transit when trailable feature has been operated by a car because of an obstruction at this point, indication light is agree with the position of the lever. The switch lever is a large toggle switch that is designed to be impossible to leave it on center of the drive between the lever and the yoke is deposited so that the lever is moved and the yoke and the contacts are also moved. The lock is attached with the bottom of the lever consists of the magnet armature operating with the plunger. When the lock is energized with the obstruction of the magnet, obstructs the movement of the yoke that prevents the opening of the contacts for the movement of the switch machine lead completed. The skate lever is a small toggle switch and not equipped with the additional is not equipped with additional features. The toggle is actuated by spring pressure only. No indication is provided with the sense that in most cases the operator can see the skate when it moves. The control machine in Figure 44, the tower of the junctions, is equipped with the switch turning of the switch lights on and off, dimming them at night, the push button, the resetting the main circuit breaker in the poorhouse with another sound of the siren called the maintainer. Indicational lights are provided with the show that the either alternating current or direct current power is off. Hump signal indications were repeated in the tower switch to be provided with so that the operator can see the hump signal at the top at stop, regardless of the desired hump master. If the cars are being cut off too fast, there is an adjacent accident that might require the stopping of the hump operation. Figure 43 shows the electrical control machine with the junction switch towers. Electrical pneumatic system. The control machines are shown in Figure 45 and 46. The retard switch levers in a horizontal movement. The open position of the retard, the normal position of the switch beginning with the left. The skate lever, the forward, the backward movement of the normal position being away from the operator. The control machine illustrated in Figure 45 is slightly different lever arrangement that can be usually provided in the skate levers are grouped in much a way the same way the tracks. Figure 45 shows the electropneumatic control machine. The retarder lever has 5 positions open to the left and successfully 4 positions toward the right in the 4 steps of retardation. The number of the plate figure 46 fastened to the control panel with the corresponding number to which the lever position. The operator, however, soon gets to know the field position of the lever. They seldom how to look and then see what position lever is. The retarder lever is held with the various position by a spring back with the ball dropping into the notches quadrant actuated lever handling banking each of the position positive. The switch lever has 2 positions normally in left of and to the reverse of the right. Indication lights are located in the figure 46 lever is normally positioned with the normal indication light with reverse position, reverse indication light. Indication lights are not displayed with the track circuit occupied with the giving of the operator information as the location of the curve. There is no lack of the other on the lever itself with the switch control with the circuit provided with the circuit locking with the track circuit that's occupied. The switch lever is provided with the toggles, so the design lever must move to the one position over the other. The skate lever is a toggle of the 2 position on and off the controlled machine into the first tower. It is often equipped with auxiliary apparatus for lever control of the switching lights and a siren to call the maintainer, often indicating lights, repeating the indication of the hump signal with the master control by the operator can set the hump signals at stop in case of the accident was go other necessities regardless of the position of humping signal controller. See figure 54. Figure 48, the electropneumatic control machine panel. Your skate control levers, the number of the plate, the car retarder control levers, the switch indication lamps, and the switch control levers. Power plant. The type of equipment of the power plant depends on the type of the power retarder, the size of the yard. Usually the commercial source for the power brought for the yard, but the converter is required depending upon the apparatus characteristic operation. Occasionally the power is generated by the railroad company. Even so, conversion is provided. The general principle of the power is large enough the capacity to operate the retarder system until the maximum depending demand of the traffic. Reverse power is provided with the commercial source that fails the plant that can be operated a period of time. Electrical system. Typical layout of the power plant layout of the electrical system is shown in figure 47. The retarder switch and skates are operated with the direct current. The track circuit is a single system. All indication lights are operated with the alternating currents. Communication system, especially teletype system, may be either alternating or current or direct current. Usually the commercial source of the alternating current is supplied with the yard and then converted with the direct current transformed into the proper voltage. Voltage and alternate current is at the power plant. A number of different methods employed with the two, which are described and some plants over-compound with the motor generator normally supplying 250 volts with a peak of 265, and it is used to operate the retarder. This generator is capable of delivering 400 to 500 amperes without voltage dropping below 230. Easily duplicated with motor generators or installed with the operating, can be alternated from one to another, leaving at least one of them free from the maintenance of the purpose. A storage battery varying from 100 to 60 to 300 amperes per hour in capacity used with reserve. Sometimes the battery is divided one half being used with the operating system, switches, gates, retarder controls, while the other half is being charged. When the main source of the alternating current fails, the battery is automatically cut into the feeders of the plants, and operating is continued without interruption. The battery is charged either by a motor generator or mercury arc rectifier. In other plants, as shown in Figure 48, the diverter pole motor generator is used to operating the retarders the floating of the storage battery of the generator is designed. For example, 100 amperes can be taken directly from the generator for operation. If more than 100 amperes are required, the current excess for the amount is taken from the battery. In some cases, induction motors is used to drive the generator. For the other, synchronized motors is used to secure the benefits of the derived current, correcting the power factor with the entire system, which may include the shop engine house. This, as many of the instances ever, affects substantial savings in cost and power. The main source of the power fails of the battery being permanently connected automatically feeds the retarder system. Also, the diverter pole generator with the operates the motor with the power plant is equipped with the synchronize the motor. The active the operating the diverting pole generated the motor device drives synchronizing motor, which then becomes Alright, typical power plant for electrical system. You have your 17 cells per row of two filters of door, battery room with 120 cell lead batteries. These have 13 cells from pure power of two tires and 17 cells from per two row of two tires. You have a light transformer with a 12-volt AC section, light transformer, 110 AC section, line disconnection, switchboard, cable terminal housing, automatic starter, DC AC motor, emergency AC, DC AC, 265 volt, 110 volt, or 60 hertz, 1 kilowatt, a gas engine generator of 260 volts DC or 10 or 15 kilowatt, starters and motor generator 265 DC or 10 watts. Figure 49 shows the power plant diverter pole motor generator. Alternating current generator, the alternator control, cut off the alternating current, the unit from the main source, alternating current cut off, then onto the synchronized motor acting. The generator will be noted with in this way both the alternating and directing current are supplied by the operating of the retarded system, whether the units will be alternating with direct current, but this was to be done with the interpretation and service. The switchboard is equipped with various controls that are necessary for the starting and the stop of the generator, is measuring the current and the power, measuring the ground selection of the feeder circuits, etc. The main feeders of the retarded circuit are controlled by the overload circuit breaker, which is interlocked with the contacts are usually indicating whether or not it is used. The indication is taken with one of the towers so that the direct current power is interpreted. The operator can reset the circuit breaker immediately without calling in a maintainer. The main source of the alternator is controlled by automatically so that the alternating current source of the fails the line, it will be cut into the plant. As an indication of the given is the tower circuit plan. Figure 49 shows the typical wiring of the power plant using divert pole type. The motor generator, the direct current of 265 volts from the generator flows from the overload of the relay coil for the main circuit breaker that connects that extend over the several yard units with the reverse current relay contact normal position N shown with the auxiliary relay energized with the normal contact reverse current relay. Alright, this figure 49 shows a diagram of the power plant with the divert pole generators, the synchronizing motor generator going into the motor starter, also into three brakes, three circuit brakes, and also three brakes, and transfer relay, indicating relay, AC off indication, located tower, loudspeaker, lever indication light, switch lights, hump signals, track circuits. On the other side of the engine, the auxiliary relay, reverse current relay going through a shunt neutral wire contract of 115 volts. Overload relay, circuit breaker reset, DC off indication, located tower, DC AF off, gone, and contact, generator feeders and switch retarders, controls, and teletypes. Alternating current for the 144 440 volt alternating current from a 440 volts line energizes the relay through the front contacts feed the primarily with 3 kilovolt transform with a supplies alternating code for the 80 or 110 volt for the hour units. In the event of overload, the overload relay with the contact open and de-energize the main circuit breaker. Contact with the brake tip out and opens with the main 265 volt direct current circuit. Circuit breaker can be reset with the main push button of the power station of the nearest timer. When alternating with the current power failures occur with the direct current of the 265 volts, the storage battery serves the plant with the generator inverts for the operator with the motor, and the storage battery the reverse current relay versus the contact, assuming they are positioned thereby, shunting of the coil for the auxiliary relay, opening of the front contact, trips the motor starter, thereby opening the contacts, preventing the synchronizing motor, and not opening the alternating supply current, or alternating current 144 volts for feeding the back of the 140 volt line. Alternating current for the alternator is now supplied through the back contacts of the relay 1, which is de-energized, but the alternating current failure occurred with the primary with 3 kilovolts a transformer from the transformer of the various yard units. Alright, the electropneumatic system. The power requirements of the electropneumatic system car retarder system consists of the supply of 12 volt direct current energy and supply with the compressed air approximately 100 pounds per pressure, with the supplying alternate current with the charged battery. Sometimes the compressor operation is also required. 12 volt direct current energy is usually supplied with the storage battery charged in the copper oxide rectifier in Figure 50. Figure 50 shows the storage battery and charging rectifiers. Figure 51 shows storage tanks and atmospheric aftercoolers. Figure 52 shows motor-driven air compressors. Alright, your many hump yards are located near the car of the locomotive, which use the considerable amount of compressed air already provided with the compressor plants. The majority with electropneumatic retarder installation compressed air supplied with the central plant. Sometimes it's advisable to install the additional storage tank and atmospheric coolers near the retarders, which are aligned with the central compressor plant tied with the retarder system, such as the installation shown in Figure 51, where the central compressor plant is not available with other means but must be provided. Usually, small powerhouses is built with a 2 or 3 compressor storage batteries, rectifier switchboards, and seldom used. But the 2 compressors used with each of the capacity taken care of the maximum condition, one being held in reverse. The 3 compressors used in normal running with the second condition require the third held in reserve. Some compressors are usually motor driven, the automatic in their operation. Figure 52 illustrates such compressors. Just outside of the powerhouse installation, the storage tanks after coolers provided in the Figure 51, similar to the sometimes provided with the air obtained with the central point. The problem with provision of alternating current supply varies in the local conditions, commercial power available, and existing facilities, so that there is no definite general practice has developed. In emergency storage batteries provide sufficient reserve with supplying the direct current for emergency compressed air, then usually a convenient connection made with the air piping system, in which such a way that a locomotive air pump can supply with the compressed air into the air from the system. Signal system. Signals are required to control the movement of the trains to and from the hump yard, indicated with the speed at which the trains are to be pushed over the hump and protect the movements in switching area. The hump signal located in the hump governs the movement from any of the track of the receiving yards. Instructions are given when the hump engine grooves, and they are more than one, which comes at first. Repeater signals are, when used, located with frequently intervals so that air and foggy weather and enginemen are able to determine the indication of the humping lights at all times. This aspect of indication recommends a signal section association American Railroad as follows. The aspect are: red means stop, green means proceed at normal hump speed, yellow means proceed at medium hump speed, yellow means proceed at slow hump speed, and flashing green means back up. In some installations described in this chapter, the aspects indication are as follows: green, hump fast and bring train to the hump; yellow, hump slow; red, stop; and yellow, over red, back up. Some installation of double red with a backup signal, but it's in case of the lamp failure, and more restrictive signal which is displayed. Trimmer signal is necessary for the controlling of the movement of the engine through the switching area. The switch targets and lights are usually indicated with the position. Each switch for the engine of the classification track is not allowed to move to the switching area until the switches are in proper position, even through the trimmer signal, as may be displayed in the movements through the switching area. The aspects indicated with recommend the single section Association of American Railroad as followed: red stop and yellow trim. And some indications described in this chapter, the aspect indications are used as: yellow permits move through the switching area and being governed by switching targets and lights; red means stay in the clear; and the controller of the operating signal is mounted at the hump near the track that then is desired, but the switchman can reach the lever as he walks along the side of the train. Different types of signal systems are used, for example, the light signal, Semaphore, or cab signal. When Semaphore light signal is used, one is located with the hump, as shown in Figure 53, while others are located out along the hump lead and sometimes at a point halfway down the receiving yard, so that to provide an indication for the engine man under all the conditions. Some yards mass are located about 800 feet apart, and the signal indicated with both directions and given minimum range of vision of 100 feet. This was found with the advantage of the heavy fog. When cab signals is used, the repeater signals are not installed. They're usually hump signals in play for the movement of the road. Engines frequently pass over the hump after leaving air trains in the receiving yard. The yard engines are not used regularly in hump service. The continuous inductive system developing automatic train control using cab signals indication provided with the code frequencies transmitted to the rail through the wire attached with the rails back over the line cut wire. The circuits involved an individual receiving track selected with the switching control operated with the switch points at the hump at the end of the yard, in which the arrangement of the priority of the trains moving out of the yard receiving yard can be set up, whereas the fixed signals of the engine man can be instructed prior to the leaving of the hump. Figure 58 shows the hump signal with the controller. In some yards, the track circuit is located with the track approaching with the hump. They use the interlocking hump signal with the trimmer signal within such a way that both signals may be clearly if the track circuit is not occupied. The permit is the trimmer engine to work with the switching area with the same time of the train being brought to the hump provides for the display of the stopping indication hump signals. As soon as the first car of the train arrives at the hump, the track circuit extends far enough to the head of the hump to give the engine man time to observe the change in the indication stop of the train. The number of the yards of the track circuit does not affect the interlocking the hump and the signals is in the different purposes just described. In these cases, the green is given by the bring of the hump yard, but at the first car shuns with the track circuit except to change the yellow normal hump speed. See Figure 54. This particular advantage is led by the humping rather than long. A special type of controller is used to control the hump signal. It is usually located enclosed with the track near the hump's master's office, as shown in Figure 53 and 55. In the controls shown in Figure 55 and 56, final 5 positions are used: the hump fast, hump medium, and hump slow, and stop and back up. In many cases, the hump medium indication is not used. Our Figure 54 shows the retarded signal system circuits. The first tower, master control, stop, clear, red, yellow, green, and then hump. They do at the hump signal controller stop, backup, stop, slow, medium, fast. Trimmer signal controls the stop, NR, trimmer signals, hump signal, and repeater signals. If the controller shown in 56 is modified with the interlock used for selecting a circuit, the trimmer circle is being used and the lever is control located with the same housing. Indication lights shown on the top under the hood, repeating the indications displayed on the hump signal. Trimmer signals when it is used, the relay of the controllers and signals are located in the lower half of the housing. Figure 56 shows the hump signal controller. If the controller shown in 55, the selection of the circuits is made by the rotation of the roller equipped with the suitable circuit. The controller's end connected directly to the operating lever with the controller. Small lever is the lower part of the controller, the trim signal controller, and it has 2 positions: stop and trim. The controller's trim signal lever has a hump signal lever and can be mechanically interlocked with some of the trimmer and signal lever cannot be in trim position unless the hump signal lever is in the stop of the backup position. The number and installation interlocking has been accomplished with the circuit arrangement instead of mechanically. The circuit used for the controller shown in 55 is illustrated in 54. When the circuit no relays are used except with the connection with the appropriate track circuit. Communication system. Means of communication is important as being necessary to transmit the car list with the hump master operated for this, as well as they know the tracks which cars to be switched. The verbal communication is necessary in case of the changes have to be made with lists due to the errors and tabulation due to the changing of the assignment of the classification. And Figure 56 shows the hump signal controller. Teletype. The teletype system consists of the master sending of the machine, usually located with the yard master. The machine not only sends the information to the various locations around the yard, but also prints the copy of the yard master office received with the machines located in the hump and each of the control towers. The machine is mounted with a steel frame, the understructure provided with the soundproof housing, and shown in letter left in Figure 44. Pneumatic tube. The pneumatic tubes consist of tubes extending from one point to another machine being used with each end of the introduced air beyond the carrier, driving through the message transmitted with the maintenance of the apparatus. Tubes connect the yard office with the receiving departure yards with the transmitting way wheels. Occasionally, the hump office. Each of the towers transmit the hump list for the operators. The tubes are used for a purpose. The last name teletyping system is not used. Telephones are located in the yard off the towers and other points where required. An additional loudspeaker system sometimes used. The receiver and the horn installation illustrated in Figure 53 and the transmitter shown in 54. The locomotive communication, the system of the communication with the locomotive is provided with one or more of the two ways communication, usually between the hump master and the engine man, humper, and trimmer engines. In two-way system, the transmitting of the receiving equipment with the loudspeaker is located with the hump office. The carrier with the locomotive is generally involved with the humping operation. One-way system, the humping office is only with the transmitter. Locomotives only receive the equipment with the loudspeaker. The reach station can be provided with a visual indicator that indicates whether or not the system operated with the power operation may be derived from whatever the source is, either at the hump office on the locomotive. Loudspeaker system is usually initiated between the humpster and hump conductor retarder towers, usually changed with switch lights, etc. Recently, talkback loudspeakers installation have been made with the given instruction to receive information from the field man and car inspector, similar employees. Main branch and connections are installed with the same general manner as covered within Chapter 18, Electromagnetic Interlocking. The usual wire practice filed with the interlocking is filed with the retarder system. Flooding light. Flooding light is very important with the retarder operation since it's a necessity that the operators see the cars in their location respectively. That switch light switches the control speed of the car through the switches at the proper time. The typical layout of the floodlight is shown in Figure 57. Alright, hot oil plant. In several winter weather, some difficulties experienced with the free running of the empty cars into the clear hot oil introduced the journal boxes as the cars move over the humps and tends to reduce the rolling resistance and thereby provides better operation. An oil tank arrangement with the heating installed with approximately 100 feet ahead of the crest of the hump. The oil is taken through the underground pipes, one pipe to each end of the track, and a hose fitted with the nozzles connected. At this point, the air pressure is applied with the tank oil, which provides the pressure to the nozzle. The journal box covers are lifted, and the inspector of the receiving yard at the cars move over the hump and on each of the track introduce a small amount of oil directly to the journal boxes, then close the journal boxes. See Figure 58. Figure 57 shows the floodlight floodlight layout, and Figure 58 shows the hot oil injector. And that concludes Tape 2 of American Railway Principles and American Railway Signal Principle Practices, Chapter 21, Hump Yard System.